Configuring Failover Clustering in Windows Server 2012. The content in this nugget follows hot on the heels of what we covered in the previous nugget on network load balancing. I hope that you're following these nugget movies sequentially so we can make use of building upon concepts as we move along. You'll recall in the previous nugget we differentiated a little bit between NLB and failover clustering. In this nugget we're going to concentrate strictly speaking on application or service level high availability. The Microsoft team who does high availability, their current buzzword as of 2013 is actually continuous availability because their goal is to allow systems administrators to provide services to their users with no downtime. That is to say, even a scheduled bit of downtime still keeps the service on its feet. In order to do that, we need a redundancy solution. Failover clustering squarely meets that need in box in Windows Server 2012. We'll understand by the end of this nugget exactly how failover clustering works in Windows Server, the storage requirements, the networking best practices, the click-through procedure for creating a cluster configuration, and then adding workloads to a failover cluster. The term in Windows Server 2012 roles. If you've used clustering in Windows Server 2008 R2, you were used to the concept of the resource. It's the same idea. You're taking some workload, whether it's virtual machines or a file share, and you're making it highly available such that the loss of a host server will still keep the service on its feet because another node in the cluster will take ownership of that role or resource. So to that end, we're going to focus in particular on continuously available file shares using a new feature called Scale Out File Server, and we'll also look at highly available virtual machines. Now in 2013, cloud infrastructure, public cloud, private cloud, and hybrid cloud is all the rage, and virtualization is the foundational layer of cloud-based services. Thus, if we're virtualizing servers or even desktops, we want to make sure to provide for continuous availability. More on that later. We'll finish this nugget with a bit on monitoring clusters. It's one thing to plan your clustering in your VM infrastructure. It's another thing to implement it, and then yet it's another thing on top of that to monitor over time the behavior of your cluster and your highly available roles. We're going to look at a brand new feature in Server 2012 called cluster-aware updating, which those of you who manage many cluster-aware resources are going to love. As your cluster size goes up, so does the time it takes to keep those nodes up to date with Windows Update or WSUS. You're going to absolutely love that, I think. And also VM monitoring, which enables us to drill through a Hyper-V server into the virtual machine, into the guest operating system, down to the service level, and receive alerts that bubble up to the host when things go kerflunky. Enough preliminaries. Let's get started. First, of course, we have our fundamental vocabulary. We can't very well learn to plan, implement, monitor, and troubleshoot failover clustering unless and until we understand exactly what it is and why it's useful. Failover clustering is not a Microsoft concept, but we're going to be concentrating in Microsoft's inbox implementation. Failover clustering is intrinsically tied to high availability. So actually, before we define failover clustering, what does HA or high availability mean? High availability is a service level for a given app or service. The buzzword that Microsoft uses all the time is workload. You might have in your business one or more line of business applications that read and write to SQL Server database, let's say, and you have, again, a service level, perhaps an SLA, a service level agreement contract, to guarantee a particular level of uptime for that data. Well, how are you going to provide that service level? Well, you need to develop some kind of redundancy. So therefore, failover clustering is a high availability method that protects a given service or application from downtime. Now, we know as Windows administrators, there are times where we need to administratively take down a box. Maybe it's just as simple as applying an update and rebooting, or it might be as invasive as actually needing to power off the server to perform a hardware swap out or some such thing. Well, with failover clustering, we can do that much more easily because, as we'll see in just a moment, we've built in redundancy at the server level. We have so-called nodes that participate in a given service or application. And if we remove one node, or maybe even more than one node from the cluster, we still have remaining nodes that can serve those applications and services to our users. Okay? Wikipedia is one of my favorite online references, and yes, the standard rules apply. You want to be careful not to take Wikipedia as ultimate gospel, because after all, it is a user-created and edited encyclopedia. However, their article on high availability is pretty good. In particular, I want to draw your attention to this section called percentage calculation. I mentioned that high availability refers in many cases to a service level agreement, an actual contract between your IT department with its constituents that guarantees a particular level of uptime. And those are important agreements because if you fail to meet those agreements, you could be on the hook for charges or even more. So this table shows us typical percentages given when we speak of a service and its high availability status. You'll often see nines being thrown around. 2 nines, 3 nines, 4 nines, 5 nines, 6 nines. Now, if a company offers a service and guarantees 99% uptime, that may seem like a lot of availability. However, that turns out to 3.5 days per year of estimated downtime. An hour and a half per week. That's not really good when we think of businesses operating 24/7. The gold standard is typically 5 nines, 99.99%, which allows for 5.5 minutes of downtime per year, 6 seconds per week. Now, can you guarantee that without redundancy? Probably not. But as we move more and more toward cloud-based services that use virtualization, and we're also using failover clustering to provide redundancy, Windows Server 2012 allows us in-box to provide redundancy for our network interface cards, NIC teaming. We'll see that. If I have time in the demo for this nugget, I'll show it to you, but certainly by the end of this training, we'll have worked with that. That's how we provide for high availability. Now, when you're clustering, you have two words here, failover and failback. I mentioned taking a server offline administratively. That's one scenario. But what about the other scenario that none of us really want to talk about, but we have to? And that is unexpected downtime. Stuff happens. It could be big catastrophes like a tornado strike, or it could just be a heavy storm that knocks down power lines. Whatever the case may be, you may lose one or more servers. And with virtualization, the stakes go up big time because you might have a Hyper-V server that's virtualizing a whole bunch of applications and services for your users. And if the host goes offline, you've knocked out a whole bunch of virtual servers in one fell swoop. Failover refers to the automatic transition of these highly available resources when a node goes offline. So if you have, in a simple case, a 2-node cluster, you've got node A and node B, and A has a bunch of virtual machines hosted on it. If A were to go offline unexpectedly, those resources would fail over transparently to B. And we'll get into more of the specifics with virtual machines later, but you won't even lose connectivity to those virtual machines. They will be live migrated, to use the buzzword, over to the next available host. Isn't that awesome? Failback is simply failover in reverse. This means when A comes back online, we want our resources that were failed over to B now to come over to A. And there's a lot of things you can do there with Windows Server 2012. With VMs, as you'll learn, we can do priority. We're going to cover VM movement in the next nugget, actually. But if you have 5 high priority virtual servers and 5 lesser priority virtual machines, you can set the 5 servers up here at a higher priority such that they get live migrated first during a failover or a failback. Microsoft has done an exceptionally good job in their admixture of failover clustering and Hyper-V hypervisor stuff. No doubt. Let's spend just a moment looking at a schematic overview of failover clustering. I mentioned the term nodes. A node simply refers to a server, a physical server, that's participating in a failover cluster. Okay, and 2 is going to be your minimum. We'll look at the numbers shortly, but you can come up to 64 nodes in a single cluster in Windows Server 2012. That is a lot of boxes. And what happens in a cluster, as I said, is that you have highly available applications or services that may be hosted on each node. Typically, with Windows failover clustering, you have what's called an active-passive configuration, where you have a designated node that owns particular resources, and any other nodes in the cluster are, by definition, passive, and they can receive those workloads in the event of a failover. Now, there are some ways around that, in particular the scale-out file server that we'll see shortly, that represents an active-active situation where we have work coming in from our connections, our user connections, actually being handled by more than one node in the cluster. Now, you'll note here we have several network connections showing on these nodes. Best practice in the Microsoft documentation is that you want to separate out your network connections. Now, you have one connection that's coming out to your user base. That should be pretty straightforward. But what's neat here is that in clustering, you're abstracting your host name and IP address and your listening ports, so that when we host highly available virtual machines, or whether we're hosting a high availability file share, that gets advertised using a virtual IP address or a VIP, and you register a particular host name in DNS. You may, for instance, be doing highly available SQL Server. Now, as far as your users' applications are concerned, they're all connecting to a single host name. But behind the scenes in the actual cluster, it could be any node that's designated active for SQL Server that is actually handling that traffic. And in a failover, of course, the other box would handle that traffic. So we've got this idea of the virtualized IP address and DNS name for each clustered role. On the other side of things, what makes clustering actually happen is that your storage needs to be shared among all nodes, and hopefully that should just make sense to you intuitively. If we were doing SQL database, how could we possibly, it's technically possible using replication and log shipping and all that, where we could keep the databases on each node, but that defeats the whole purpose of high availability, especially if a node goes offline suddenly. If we keep the databases on a shared storage device, this could be iSCSI, Fiber Channel, SAS, whatever. We'll talk about that a little bit later. We can run the binaries, the SQL Server binaries on each node, and point each of those installed instances down to the database files in the shared storage. So that's going to require best practice, a separate Ethernet or Fiber Channel connection. Third and finally, the nodes need some method for determining who's online and who's not. That is, again, best practice, a third network connection that represents the heartbeat channel for those nodes. And as we're going to learn, heartbeat messages can flow not only between nodes, but between the nodes and your shared storage, and then even possibly between your nodes and a file share that an administrator designates. Failover clustering improvements in Server 2012. As I said, Microsoft seriously ramped up failover clustering in Server 2012. First of all, scalability. Each cluster can now have up to 64 nodes, 4,000 VMs per cluster. That's tremendous. 4,000, you might think, do I have need for 4,000 virtual servers? Remember that those VMs don't have to run Windows Server. You could be doing what's called virtual desktop infrastructure and roll out user desktops as VMs as well. Now that's a huge ramp up from Windows Server 2008, which supported 16-node or 16-way clusters, 1,000 VMs per cluster. CSVs, which we haven't yet talked about, that's the cluster shared volume. Those were introduced in Windows Server 2008 R2 strictly for the Hyper-V workload. Now we can use them not only for Hyper-V, but also for file sharing services. We have a new version of Server Message Block called SMB3, and we'll talk about SOFS throughout this training. It's a way to provide fault-tolerant file shares. Cluster-aware updating allows you literally to configure a cluster to update itself with no downtime. More on that later. Cluster validation has historically been a slow, sticky point in Windows failover clustering. The team optimized the code such that you have not only more comprehensive validation of your cluster configuration, but it's leagues faster than it used to be. And finally, the old cluster.exe command line utility is gone, replaced with a robust module filled with failover clustering PowerShell commandlets. No big surprise there, I'm sure you would agree. Now I mentioned CSVs. Have you used those at all? If you've done clustering in Windows Server 2008 R2, did you start to use cluster shared volumes? Now if you weren't doing Hyper-V workloads with failover clustering, then the answer is probably no, because you couldn't use CSVs for anything else. If you were doing highly available VMs, CSVs are really your only choice. Historically, you probably remember, a cluster node can't see shared storage unless it becomes the active node for a resource. So the only place where a particular logical unit number, or LUN, this refers to a piece or a segment of your storage area network, your SAN. If you need to fail over a virtual machine from host 1 to host 2, that's going to require unmounting and remounting LUNs. Because again, the idea is a cluster node can only mount one LUN, or should I say, one LUN can only be mounted by one cluster node at a time. That's a big problem performance-wise. So failing over a VM resource meant failing over the entire LUN. That involves downtime for anything else that happens to be on that LUN. In short, friends, cluster shared volumes enable multiple cluster nodes to access a single LUN concurrently. And I've put together a simple schematic using Microsoft Visio to show you what I mean. Let's say we have two LUNs. These are shared units of storage. Let's assume iSCSI for the sake of conversation. And typically, if node 1 is hosting two VMs in this resource on LUN 1, if we need to fail over those guys to node 2, that's going to require unmounting the whole thing. Now, what if we just wanted to bring or live migrate these VMs over? What's going to happen to the other resources that are attached to that LUN? You see? In a nutshell, when you have cluster shared volume storage, CSV storage, first of all, every node in the cluster has a simultaneous connection to the same LUN. That's why it's called a cluster shared volume. Now, you might think normally when you mount a LUN, it involves spawning a drive letter, all that good stuff. CSVs actually show up as local mounts on the C drive of each node. We'll discuss that in the slide when we go back to the text. But you could look at it here that each VM has a slice of that CSV. So if we want to live migrate both of those VMs over to node 2, or if we even just want to take one, note that we're not having to unhook and rehook the entire LUN and perturb any other resources that are on that LUN. You can just change a pointer basically to another node on the fly. Isn't that awesome? So in summary, CSVs give you incredible flexibility. There's really no reason, in my opinion, why you shouldn't use CSVs when you're doing highly available virtual machines. And by way of new feature, Microsoft now gives us scale-out file server where you can put file share content, shared folders, in a CSV. Again, you have a connection and a local mount point to that shared folder on any node. So the point is that share is up, online, and available even if a node goes offline that owns it. That local mount point, as I said, is by default C cluster storage, and then each CSV gets a new integer, volume 1, volume 2, volume 3. You might be thinking, how is that going to affect disk space utilization on my server? What if this volume 1 CSV is 25 gigabytes or 250 gigabytes? The good news is that the local mount point is essentially a portal into the LUN. It's not occupying any space. It actually shows up. The icon, as you'll see in the demo, makes you think of an alias or a symbolic link. And these last two bullet points I've already addressed. Quorum is a concept we need to understand. It's not as difficult as you might think at first blush. Quorum refers to a minimum number, a minimum quantity required to get some work done. When we think of a business meeting, you might say, well, we have 10 people who need to be at the meeting, but quorum would be 6. In other words, if we have quorum, we can carry votes. We can use our Robert's Rule of Order and vote on stuff and get work done. Similarly, in a failover cluster, quorum represents the number of nodes or elements that are required to keep the cluster going. Now, what does an element mean? Don't we just talk about the nodes, the actual hardware, the servers that are part of a cluster? Not necessarily, and there's very good reason for this. An element can be a node, but it can also be the shared storage, can also be an arbitrary file share that gets a vote in the quorum. Essentially, quorum means each element votes periodically. Do we have enough to keep this cluster going? Enough resources? The quorum type can be left to the OS. Microsoft recommends you typically let failover clustering feature determine quorum itself. You can override that as an administrator if you want to. Here's the money here. You need to understand the specific quorum types. We have node majority, node and disk majority, node and file share majority, and no majority. Now again, this isn't as confusing as you might think. Node majority means that only your cluster nodes have a vote in quorum, and if you have more than half voting yes, we're online, the cluster continues. Now this is what we use and what Windows will select if you have an odd number of nodes. So let's say you have a 3-node cluster. Windows would set this to node majority because the loss of one node, we still have 2 out of 3 online, you see. But what if we have 4 nodes? If we lose 2 nodes, are we online or offline? We've got 50% voting yay and 50% implicitly voting nay due to their offline status. If you have an even number of nodes, Windows will choose node and disk majority. And basically, your shared storage serves as a voting member or a disk witness. Also, we have node and file share majority, which instead of using a disk witness, uses an arbitrary file share. So if the file share is online, it votes yes, and then your nodes vote or not, as the case may be. That again is optimized for even number of nodes so you don't wind up with a deadlock or a tie. Finally, and this is kind of cool, no majority is where you're so concerned with keeping the cluster online, you're willing to go to the last node standing. Of course, you still have to have connectivity to the shared disk. That should just make sense. But even if you go from, say, 3 nodes down to just 1, the cluster will still continue because you have that high availability requirement. So you may decide, even if Windows selects one of the node majority types, to override that and set no majority to keep your cluster as available as possible. It's up to you and your business needs. What are our networking and storage options in Windows Server 2012 failover clustering? Well, in terms of networking, we've already talked about this in the schematic. You've got your quote-unquote public. This could still be using an RFC 1918 private address, but public in terms of the networking that you expose to your user population, your constituents. We have our storage connection, which is Fiber Channel or iSCSI typically, more on that in a second. And then your private network refers to your cluster heartbeat messages. Those heartbeat messages, remember from NLB, go out once a second, and 5 consecutive misses on a heartbeat means that that node is offline. Heartbeats use UDP unicast. It's nice that we're not doing broadcast like we used to. This is going to cut down on just noise and chatter, and it operates, the heartbeat messages operate on port 3343. That's just FYI. For your shared storage, we can use SAS disk. This is serial attached SCSI. Essentially, it's your SATA form factor taking advantage of the speed and performance of SCSI. And we can actually use that as shared storage. You can use storage spaces and even Windows Server 2012 iSCSI Target. You can build an iSCSI SAN server directly from Windows Server 2012. Isn't that cool? Actually, failover clustering and iSCSI Target are both neat inbox features because you're not paying any extra for them. Just like in the previous nugget, we can use NLB in the absence of shelling out big money for a hardware load balancing solution. Now, why would you want to go with iSCSI or Fiber Channel, given that iSCSI is much, much cheaper than Fiber Channel? You can leverage your existing Ethernet backbone, and Fiber Channel requires separate cards, host bus adapters, or HBAs as they're called, cabling, fiber channel switches, and all that. It's proprietary. Well, basically, it's a question of, do you already have Fiber Channel? Customers who already have Fiber Channel are going to want to stick with it because of its cost. Otherwise, you will get your best bang for your buck from iSCSI. I will say parenthetically that Hyper-V in Windows Server 2012 supports virtual fiber channel, such that you can actually leverage your physical fiber channel SAN inside your virtual machines in Hyper-V. What are the requirements needed to build a failover cluster? Best advice I have for you is do what you can to certify all your hardware prior to implementation, actually prior to purchase. The reason for this, of course, is that we're generally investing quite a bit of money in hardware and network infrastructure, and we want to minimize the possibility of incompatibilities or things breaking because they don't play well together. The hardware on each node ideally should be identical, so if you're buying servers for a cluster configuration, make them identical because you really can't go wrong that way. At least they should be very close. The NICs need to use identical settings. They may not necessarily need to be the same exact NIC, make, and model, but as far as the Ethernet settings, duplexing, flow control, those settings all need to match. Best practice from Microsoft is that your nodes should all have matching server roles. You can combine editions of Windows Server 2012. You can also use any GUI layer, that is to say server core, which is Microsoft's suggested server configuration, the server with a GUI, which is the other extreme where you have the full Windows treatment, and then there's the minimal server interface, which is a combination where you have server core but with a few of the graphical tools like Server Manager, iSCSI Initiator, etc. Finally, be sure to run those validation tests. They're more comprehensive than they were in Windows Server 2008 R2. The tests are much faster, and new in Windows Server 2012, we can actually tweak what's being tested. If we've absolutely double Dutch certified our storage, we can save even more time during validation and uncheck that storage option. Now, validation can be skipped, but the reason why it's so important, besides giving you some peace of mind that stuff will work, is that you need to pass validation in order to get Microsoft support. That notion of supported, some administrators think that means, oh, well, if Microsoft supports clusters that have been validated, then that must mean they say you should do it because it's a good idea. No, actually, we're talking service level agreement stuff, such that if you're not running in a supported configuration, Microsoft could say take a long walk because you're not in compliance with our rules, you see. I know you're hot to get into the demo, so am I, just a little bit more. Monitoring failover clusters, there's lots that we can do right out of the box. You have your event logs, we have performance and reliability monitor, data collector sets, etc. We can do event tracing with the trace-rpt command line tool. The cluster validation tool, as you'll see in the demo, generates these self-contained MHT files that are very nice. They're interactive websites, really, self-contained websites that are very rich with information. And then new in Server 2012, VM monitoring. Now what this is, it's a command line only tool, it's PowerShell interface only, where you can actually detect a failure within your virtual machines. So you can drill down through your layers. You have your OS layer, your Hyper-V hypervisor, then you have your virtual machine object with its own OS, right down to the service level. And you can get alerted up here in the OS and in Hyper-V if a service stops or experiences some state besides just running. Isn't that great? So while you can't monitor applications, like if you were running a VM with Exchange Server in it, you couldn't, out of the box, without using System Center, monitor aspects of Exchange's running state. But you can, for instance, set a monitor on the information store, let's say, which runs as a service. So if something goes wrong with that, then you could get that alert. This is meant as a cheaper alternative to the System Center tools, like System Center Operations Manager. Those are much, much, much more detailed and robust monitoring solutions. As a matter of fact, I'll mention it again later, but if you're going to look at any System Center tool and you have any interest at all in Hyper-V, in the private cloud, you want to look at System Center Virtual Machine Manager 2012 because it seamlessly integrates your Hyper-V hypervisor with failover clustering, with network load balancing. It just blends everything together. It's not the easiest program to learn, but if you're a CBT Nuggets member, you can check out my colleague Greg Shields, who does a great job with that training. A word about cluster-aware updating. The problem here is, as you scale out your cluster, you might have a couple racks, especially with Windows Server 2012. You can have up to 64 nodes in a cluster. It would be a full-time job to have to touch each one of those nodes. The traditional way to run updates is to move all the resources off a node to another node, do your updates, reboot, get everything all hunky-dory, bring back those hosted resources, then move to the next node, rinse and repeat. That's terrible. Cluster-aware updating enables us to transparently do all that stuff. Now, you can manage cluster-aware updating from your administrative workstation. You could use the remote server administration tools. It's actually, CAU is part of the failover cluster administrative tools. Or you could actually set up CAU within the clusters on one of your nodes and have it be a self-updating deal. But essentially what's happening is that CAU transparently will one by one take a node offline and draining any roles to another box. It will apply updates from Microsoft Update or Windows Server Update Service if you have that, reboot if necessary, come back online, automatically reclaim any of its hosted roles, and then we roll on to the next node. Isn't that awesome? That is all there is to it. Now, there's a lot under the hood technically that's beyond our scope, but it literally is that easy, and I'll make sure to show you that in our demo. Hello and welcome to this demo on failover clustering in Windows Server 2012. We're going to take this one step at a time, and by the end of this demo you'll understand how to create a cluster, add nodes to a cluster, configure storage and networking, work with cluster shared volumes, adding roles to a cluster, verifying failover and failback, and I think that's enough. We'll continue using failover clustering and additional nuggets on this series. Now, to give you a picture of what we're looking at here, I'll open up Disk Management Console really quickly. I've established iSCSI connections to 3 targets, although I've just set up 2. My Q drive is called Quorum. That's a 1 gigabyte disk. The Quorum disk, or the disk witness, really doesn't need to be much bigger than 512 megs, to be perfectly honest with you. And I have one additional disk. These are iSCSI targets I've connected to. They're on my SAN. They don't exist physically inside this box. We're going to do an entire nugget on storage, so I'm not going to show you all of the ins and outs of how this works. I just wanted to let you know that on both of our nodes, HV Nugget 2 and HV Nugget 3, they're both connected to shared storage, and they both have networking configured for heartbeat traffic as well as storage traffic and of course LAN traffic. Before we can do failover clustering, in addition to meeting the aforementioned hardware requirements, we have to install the failover clustering feature. We can do this through PowerShell, or we could do it through the Server Manager console, as you know. I'm going to buzz through this in Server Manager. We'll go to Manage, Add Roles and Features. Actually, before we do that, let's do Manage Add Servers to demonstrate multi-server management. You can type part of a name and click Find Now, and it will resolve all of the boxes that match that string. I'm on Nugget 2, so let me bring in Nuggets 1 and 3. I did a control click there, and then we'll use this arrow button to bring them over. This allows us to remotely administer those additional boxes, and as you see, roles and features that are installed on those boxes become available here. Even though HV Nugget 2 is not a domain controller, I can administer Active Directory now because I added HV Nugget 1 to my available servers. Okay? Also, if we go into Add Roles and Features, let me bring this up, we'll skip the first page and click Next, and do a role-based, this is 99% of the time what we'll use. You only use the Remote Desktop Services installation when you're setting up Remote Desktop Services in VDI. You'll note here that we can choose to target not only the local box, which is HV Nugget 2, but any other boxes that are connected up into Server Manager. So if we skip past roles and go into features, we can select failover clustering. Of course, I want to bring in the PowerShell module as well as the administration tools. And while we're here, let me come down to Remote Server Administration Tools, Feature Administrative Tools, and make sure that I have both of these selected here. Click Next, Install, and we'll complete this installation. I'm going to install also on HV Nugget 3. I'm not going to install on HV Nugget 1. I'll be right back. My installation succeeded on both boxes, although you're just seeing HV Nugget 2 right now. Now that we've laid down the binaries and we have our iSCSI target connection to our shared storage, it's time to validate and build the cluster. From the Tools menu, we can select Failover Cluster Manager from either node, HV Nugget 2 or HV Nugget 3. I'm going to close this right-hand Actions pane by using this guy up here to give us a little more room to breathe. I'm also going to stretch out the console tree. I want to draw your attention here to this management section. You have a whole bunch of hyperlinks here. There's some documentation links, some web-based links. Validate configuration is important to make sure that your configuration will work as expected. And of course, as I said earlier, there's the issue of, do you want to be supported by Microsoft or not? So let's click Next, and we're going to validate against both boxes, HV Nugget 2, the local box in other words, and HV Nugget 3, which is my second node. We'll click Next, and you can either do all tests, or as I said earlier, you can select tests if you want to cut down. The tests run so quickly for servers, network, and storage, I think you'll be impressed. Let's click Next. Tells us we're ready to start validation, and it gives us an indication of exactly what's going to happen. It's going to enumerate your host bus adapters for Fiber Channel or iSCSI. It's going to look at the BIOS. It's going to look at memory, OS. There's a lot going on here as far as what it's looking at. We'll click Next, and you see live progress happening, and then whether the test passed, whether there's warnings, or whether there are actual errors. Well, you'll have to take my word for it, of course, but the test didn't take long at all. And you see, we see in a small scroll box here, we can go through the results. The big news is up here. You want to see testing has completed successfully, but you see that this icon represents that I have some warnings. They're not deal breakers necessarily, but I should take a look at them. So if we hit View Report, it opens up a self-contained MHT file, self-contained HTML report, and it looks like in my network subsystem I have warning. Everything else was glowing. And this is hyperlinked, such as you can drill right in here to see what's going on. And it looks like it's found some non-operational network adapters. We're not going to worry about that. I know that this is all working fine. But you'll want to keep a copy of that file. You can, from Internet Explorer, simply do a save as, or you can print it or convert it to PDF, whatever you want, although you'll lose the interactivity if you do that. Note also this create the cluster now using the validated nodes. I'm going to deselect that. That would simply kick open the new cluster wizard. You can also create your cluster using this icon or this link down here, or we can right-click the root node and select create cluster. Note also you can validate the configuration. In other words, you can run the configuration wizard additional times after you've solved the problems. And again, you'll want to keep a copy of the report for your own documentation purposes and to hand off to Microsoft support if need be. Let's right-click and choose Create Cluster. Again, this is a wizard-based interface. It asks us which servers do we want to add. I'm going to add this computer as just a single node. We will add an additional node later. I want to show you that process. It asks us, are you sure you don't, well, it doesn't say are you sure, it simply says, do you want to run the validation tests? Well, I've already done so I don't need that. We can click Next. We're asked to give an administration point for the cluster. I'm going to call this NUG cluster, and it gives us which subnet it sees as a possible network for administration, and I'm going to give this a unique IP address of 111. Click Next. It validates your name has to conform to NetBIOS standards, believe it or not, 15 characters. We'll click Next, and then it spends time building the cluster resource, creating a computer object, etc. We can view a report if we want to. It tells us which quorum type it's selected. We have an odd number of clusters, so it's selected node majority, and then we'll click Finish. So now we have an object here under Failover Cluster Manager. If we expand it, we have a node for roles. These are our highly available applications and services. Of course, we don't have any yet. The nodes, where you have connectivity to each server in the cluster. Storage, where you expose your disks, your shared storage. Of course, I don't have that yet. You have a node for network connectivity. You can expand your Ethernet or your iSCSI or your fiber channel cards and review those and their status. And then we have insight into the event log filtered for cluster events. This is nice and handy that Microsoft gives us this portal. Now, what do we want to do first? Do we want a second node, or do we want to add disks to the configuration? It really doesn't matter. I'm going to add disks. We right-click under Storage, the Disks node, and select Add Disk. It will bring up any disks that it sees. And I have the two disks that are iSCSI targets on my network, one at 1 gig, the other at 5 gigs. We'll click OK, and those become resources in my cluster. Let's come back and select disks, and they're showing as online and available storage. Now, it's important that you don't commit one of these resources unless and until you determine whether you want to use clustered share volumes. Now, for my 1 gig disk, I want that to be my quorum, my disk witness. But for my other one, the 5 gigabyte drive, you'll note down here it's showing up as my local drive R NTFS file system. I do want to use CSVs for this, so we can do scale-out file server and highly available virtual machines. To do that is remarkably easy. We can simply right-click the cluster disk in question and select Add to Cluster Shared Volumes. Instantly, almost, the assigned to goes from available storage to cluster shared volume, and you'll see down here we have an object with a local path. This is an actual honest-to-goodness browsable path. See cluster storage. You notice that that shows up as a symbolic link or an alias, and it's a portal into this LUN, into this iSCSI LUN. So it shows up as CSVFS. That's not a new file system. The file system is actually NTFS. The CSVFS is nothing more really than a label or a wrapper that tells Windows that it's being used as a cluster shared volume. Now at this point we haven't allocated any cluster resources to our disks yet, but before we do that I want to add HVNugget 3 in as a node. To that end, we can right-click the Nodes node, if you'll pardon the alliteration or whatever it is I just did, and select Add Node from the shortcut menu. Yet again, a wizard, right? Get used to seeing wizards in the Failover cluster GUI. If you want to use PowerShell to do all this, more power to you. So let's select Next. We simply provide the server name, right? HVNugget 3, no big deal. It resolves the name, brings it into the selected servers list. Next. Again, we want to be careful here. Add all eligible storage to the cluster. If we leave that, then it's going to automatically bring in, well, there's really nothing to bring in. So again, I'm going to deselect that, click Next. And we have a warning. The resource cluster disk 2 is not being considered for the disk witness because the resource is not valid as a disk witness. You know why that is, right? In order to be a disk witness, you can't be a cluster shared volume. And actually, that brings up an excellent point. Namely, how do we take control and tell the Failover cluster manager which disk we want to use for quorum or not? Well, you notice that magically or automagically, Windows has selected that cluster disk 1 as the disk witness for quorum. Now we can customize that by right-clicking the cluster, NUG cluster, More Actions, Configure Cluster Quorum Settings. While we're here, we have a quick link to cluster-aware updating. We can move core cluster resources to a particular node. We can destroy or shut down the cluster, or we can migrate nodes, which of course kicks off another wizard. But anyway, we want More Actions, Configure Cluster Quorum Settings. And in this particular wizard, our choices are to let the cluster determine where the disk witness is and how it will be used. Add or change the quorum witness. This would be if Windows has selected wrongly, we can redirect to another quorum. And you can also change the majority setting and all that. I don't think I want to change a thing. Now, I said that automagically Windows made cluster disk 1 a disk witness. That really wasn't any magic to it. If we select the cluster, you'll see that Windows automatically switched from node majority to node and disk majority. Remember that with an even number of nodes, we need some tiebreaker available. So Windows Failover services automatically, not automagically, nominated cluster disk 1 as a quorum. And fortunately, that corresponds with what we wanted for that disk anyway. You understanding things so far, friends? I think it's pretty straightforward. I hope you're happy with our progress thus far. Now, what things can we do with nodes? You can find out either by right-clicking a particular node or exposing the action pane over here. It depends on your comfort level with the right mouse button. I prefer the right mouse button myself. You can change from the default roles view to a hardware summary view, depending upon what you want to see. Roles view is particularly helpful because at a glance we can see which highly available applications or services are running on a particular cluster node. What else do we have? Pausing, resuming. With pause, you can drain roles or not drain roles. Drain is going to involve an automatic migration, a live migration of those resources. That is to say, scale out file servers, shared folders, stay online. Hyper-V virtual machines do not have to be powered off. And moreover, if we're using cluster shared volumes, the users should experience nothing more than the tiniest little glitch. They'll definitely not be disconnected and reconnected unless something goes horribly wrong. We can RDP to that box. We can show critical events filtered from the event view again, event viewer. We can globally stop or start the cluster service, evict a node from a cluster, refresh, change your view, etc. Pretty straightforward. Now let's move right into high availability roles. If we right-click that guy and select Configure Role, this wizard enables us to select a role profile for high availability. And there's quite a bit to choose from, as you see. There's Distributed File System, or DFS. You'll notice that to do this, if we had a DFS tree that we wanted to be highly available, we have to install the appropriate role or feature. And it's nice that we get a warning here. Highly available DHCP, DTC, application, scripts, services, Hyper-V replica broker if you're doing highly available Hyper-V replica. If you have Windows Server 2012 iSCSI target set up, you can make that highly available. There are options here if you have other services like SQL Server or whatever that you need to be highly available. you can use the other option to specify custom options. But fortunately for scale-out file server, the file server option shows up in the list fourth down, but it tells us here that the required role or feature cannot be found on any node. So we need to install that. We can do that through PowerShell or through the Server Manager console. I'll do this through PowerShell. We'll do an install Windows feature, file services, fs file server, rsat file services. And you might be wondering, how the heck did I know what those are called? Let me go to HVNugget 3, right-click the PowerShell icon, select Run as Administrator, because we need to do it over here too. We can do a Get Windows feature, if my tab completion works. Let me try that. Get Windows feature star file star. That will return anything that matches on that name, you see. We want to see an exit code of success. That's always a good thing. Let's cancel out of this wizard and start it again. Right-click, Configure Role, File Server. This time we don't get an error. Is this going to be a general purpose file server or scale-out server for app data? Now, something I didn't mention in the whiteboard portion of the course, there's quite a bit of, not exactly controversy, but differing opinions about when to use and when not to use scale-out file server. Because of all the metadata that can fly around on your network, most professionals with whom I'm connected do not recommend scale-out file server for your end user file shares. There are other solutions for that. You may have a DFS tree, for instance, and a replication schedule. You can make that is to say DFS replica, highly available using Failover Cluster Manager, no problem. If you have an individual file share for general use, in other words, files that are opening, closing, saving, all that metadata flying around, you'll want to use the file server for general use. Scale-out is used, at least best practice, with SMB3 and cluster shared volumes for long-running file sessions. Think SQL Server database, where you have a lower number of files, and those files are open and in a relatively consistent state, metadata-wise, for periods of time. Now, you can use scale-out file server for end-user file shares. That's what I'm doing in this demo, just because it's easier to show you how it works in practice. But I just wanted to give you that background. So, for scale-out file server, we have to provide a name. And this is effectively, whack server name, share name. This is taking the place of the server name. I'm going to call this SOFS, scale-out file server. Note again the NetBIOS limitation. I find it crazy that here we are in 2013, Windows Server 2012, Windows 8, we're still making reference and having dependencies to NetBIOS. Isn't that amazing? Anyway, we'll click Next. Tells us we're ready to go. Now you're wondering, if you have any experience with clustering, why aren't we creating a virtual IP address for this resource? Well, hold that thought. I'll answer that in just a minute. That didn't take long at all. It tells us that we have a distributed network name, as it's called, of SOFS. Relevant OU is in the computer's container in ADDS, and instead of a discrete IP address, we're instead looking at our 10 subnet that's used on my LAN. Interesting. Now, once you finish, you'll need to pause for a little while before you can actually create your highly available share. If you try to create the share too early, you'll get this error message. The client access point is not ready to be used for share creation. This may be due to network propagation delays. Please try again later. So we will wait a little while. And actually, in the meantime, let me pop open DNS Manager from my domain controller and let me drill into my forward lookup zone. And I want you to see here, we have A records created for SOFS that map to my 2 nodes. So what I want you to know here is that SOFS doesn't map to a single virtual IP. The way it's architected is that it actually goes to a specific host, because remember, SOFS stores that shared resource in a cluster shared volume, and by its very nature, all hosts have a link or a nexus to that CSV, okay? Back to HVNugget 2. Let's right-click our scale-out file server role and select Add File Share from the shortcut menu. It kicks open yet another wizard. We have to have a contest at CBT Nuggets. How many wizards are contained in the Failover Cluster Manager of Windows Server 2012? That would be kind of cool. It's like those Facebook memes where you see all these overlapping triangles or rectangles and you're challenged, how many do you see, right? There are a lot of wizards in this interface. The first question we're asked before we actually denote the share is, what are we using? Server Message Block 3 or NFS? Some of that's going to depend upon whether you need to share with non-Windows operating systems. Quick is the basic, most straightforward profile, and that's what I'm going to choose here. We're asked to validate where the server resource is. Of course, that's SOFS, scale out file server role, and then where the share will be located. And it defaults to any CSVs that you've got on your box. I have just the one, so I'll select it and click Next. We're asked to provide a name. I'm going to call this Docs, some high priority corporate documentation. It tells us that the remote path to the share will be SOFS docs. Again, interestingly, this doesn't map to a server name. It's essentially a virtual server name when you think about it. Next, I would recommend you keep access-based enumeration turned off because this kicks up the metadata significantly. Enable continuous availability. Of course, we want failover to be transparent. That's why we're doing this. Do we want to allow caching? Are we going to use encryption? No. I'll just leave the default options here and click Next. This is where we can control our permissions, our discretionary access control list. If we click Customize Permissions, this is your traditional permissions dialog in Windows 8 and Windows Server 2012. I'll leave those alone for now, and we'll create the share. We can click Close, and at this point, any host on our network, I'll come back to hvnugget1 just for grins, do a Windows R, whack SOFS /docs, and you've got yourself a connection. I'm going to create a file here called test file. You know, the old typing, now is the time for all good men, etc. I'll save my work. I want this to be open, and I'll have some unsaved work here just to demonstrate that the failover really is seamless to the end user, because that's what we're going to test next, actually. We can see that the SOFS resource is contained on hvnugget 2, not hvnugget 3. So what would happen, do you think, if we just took this guy spontaneously offline by right-clicking and stopping the cluster service? Well, let me do that. Tells us, are you sure you want to? Yes. I'll come back here and continue working, continue saving, do a little more work. Any interruption? Save, etc. You know, page setup. Do you have your session? Can you customize the document? And if we come over to hvnugget 2, expand our nodes, we see hvnugget 2 is down. You see the arrow? And hvnugget 3 is happily running our scale out file server resource. Isn't that cool? Now what happens if we bring this guy back online? Start cluster service. Now you can customize whether the resource will automatically fail back. By default, it's not. You'll notice that it continues to run on another node. If I want to move this guy back to hvnugget 2, it's not a big deal. We can right-click, move. We can either let Windows choose the best possible node, or we can select the node. Of course, I just have hvnugget 2. Click OK, and that role now goes over to hvnugget 2. And again, there's no interruption over here on the user side who has a file open on that share. And again, let me go to another host, hvnugget 3, and let's do a C cluster storage, volume 1, shares, docs, and there's the file. Again, this demonstrates that the volume is in fact shared. The iSCSI target is in fact shared among your cluster nodes. Okay, we're getting short on time in this demo, so the last thing we're going to do is cluster-aware updating. As a best practice, if you plan on doing your cluster-aware updating from within the cluster, in other words, having the cluster self-update, there's a little documented prerequisite. You have to install the cluster-aware updating cluster role, and it's very easy to do. Add CAU cluster role, and you're asked, do you want to add this to your cluster? Yes or no. The default is yes, and we get our green banner that tells us progress as we go along. We always want to see an exit code of success. That's a happy day when that happens. And to open up the cluster aware updating, as I said earlier, we can do this from within the Failover Cluster Manager console. See, cluster aware updating. Another way to get to that console is through Server Manager, Tools, Cluster Aware Updating. Just for grins, I've switched over to hvnugget 1 and installed the Failover Cluster Tools just so I can get to cluster aware updating, and this box actually has an internet connection too. In the cluster aware updating dialog, we're asked to connect to a cluster. I have NUG cluster, so I'll select it and connect to it here. It shows us our nodes, and then it shows us in text format. If you're used to WSUS with nice pie charts and all that, you're not going to see that much in this interface. It's pretty stripped down actually. Basically your log and everything is just plain straight text for the most part. Although there's this generate Generate Report button, again, it doesn't look particularly cute. It's just basic metadata. First thing you'll want to do is analyze your readiness to do cluster updating. You hit that link and nothing seems to happen for a while. You get an hourglass on your mouse pointer as you see, and it tells us please wait, but we don't see any other indication that the system's not in a hung state, unfortunately. The good news here is that it looks like most everything passed. You can get a good education on the requirements for CAU by reading these analysis results, actually. I have a warning. It's not a showstopper. Everything else looks good. We can copy the results out or just close. Preview updates or apply updates depending upon your comfort level. Because the internet is not enabled on my other nodes, we're not going to be able to go many places here, unfortunately. Remember, group policy determines whether or not your cluster nodes are connecting to WSUS or to Microsoft Update. We don't configure that here. Speaking of configuration, if you want the mode of your cluster to be self-updating, that's what this gear icon is for, and this walks us through how to enable self-updating node in the cluster. Enable, for instance, you want to remove the CAU clustered role and do your administration from outside the cluster. You can do that if you want. You set a schedule. This is the default schedule, the third Tuesday of every month. As you know, I'm sure, the second Tuesday of every month is Patch Tuesday. I think they put it the week after to give you a week to approve updates in your WSUS database. These are your self-updating run options. You can check TechNet for a detailed description of this. This basically customizes how the self-updating engine works. Do you want to do recommended updates or just your core critical updates? And then you're asked to confirm and apply your self-updating options. That was a success. If you want to actually initiate an update job manually, that is to say not on a schedule, we hit Apply Updates to this cluster, and that simply hits another wizard, the final wizard we'll look at. Now you can customize these values here. You don't have to tweak them every time you run the wizard by using this guy here, Create or Modify Updating Run Profile. And again, we're asked recommended or just critical, and then update tells us once we close the wizard, which I will now, it shows us the active state of the process. You can see at a glance which node is currently receiving updates, which ones are in queue to go next. If you decide to change your mind, you can cancel the updating run, which is what I'll do right now. And finally, we have a link to the cluster management snap-in. There you have it, friends. Failover clustering in Windows Server 2012. It's never been easier to use, never been more powerful. Configuring failover clustering in Windows Server 2012 review. Boy, we covered a lot of ground in this nugget, didn't we? High availability, we understand what that means and how failover clustering and NLB, to bring in a little of our previous nugget, meet that need of not just high availability, but what the Microsoft product team likes to tell us, continuous or continual availability. We understand storage and networking ramifications and requirements for failover clustering. We understand now how to install the failover clustering role, add nodes, configure your storage, including cluster shared volumes, and then bring one or more roles or workloads online. Finally, once your cluster is up, running, operational, we tested failover and failback, and we understand how to monitor clusters using cluster-aware updating and VM monitoring. I hope you're enjoying the coverage of Hyper-V in particular, because we'll be covering that as we move on to the next nugget. I hope that this has been informative for you, and I'd like to thank you for viewing.